Hello everybody, getting ready to do 7.4 of Algebra 2 Math. There'll be part 1. If you want part 2 and part 3, email me here. 7.4, find sums of infinite and geometric series. We have a skill check here of 30 points for classwork. And then we have a notebook guide that's got 8 points involved with that as well. Teachers, here's your bell work here. Give your students about 5 minutes to complete this bell work. Okay, welcome back. Students, you should have your bell work done. These will be your solutions for your bell work. Okay, S10, so find the sum of the geometric series. Summation of 10 equals, here's our formula here for our summation here, and then we plug in here S10 equals 5 times 1 minus 2 to the 10th over 1 minus 2, and when you calculate that it comes to 5115 for first one here. And then number 2, again, here is our formula for this summation here. And then here is our plug-in here for it. S12 equals 8 times 1 minus 3 over 2, 1 minus 3 over 2, but this is to the 12th power up here. And then you get this number here, 527,345 over 256. So you should have that number, student. Okay, find sums of infinite geometric series. You found the sums of infinite of finite. Now we're going to find them for finite geometric series. So you can use a fractal. The sum, Sn, of the first n terms of an infinite series is called a partial sum. The partial sum of an infinite geometric series may have a limiting value. So for example here, example 1, consider the infinite geometric series here. Find and graph the partial sums Sn for n equals 1, 2, 3, 4, and 5. Then describe what happens to Sn as n increases. So S1 equals 1/2 equals 0.5. S2 equals 1/2 plus 1/4, which equals 0.75. And then S3 is 0.88, S4 is 0.94, and then S5 is 0.7. So what does that graph look like? From the graph, Sn appears to approach 1 as n increases. So we start here, and it goes like this, and it starts to curve like this. So it's almost like 1 is an asymptote for this series. Okay, so our first guide of practice here, partial sums. For the given series, find and graph the partial sums of Sn. N equals 1, 2, 3, 4, 5. Describe what happens to Sn as n increases. Students, this is your series, your independent practice here. Pay attention to yours. Okay, here's our problem here. Here is our sum here. So S1's 0.4, 2 over 5. Then S2 is 2/5 plus 4/25, which equals 0.56. And then S3 is 0.62. S4 is 0.65. And then 0.66 for S5. As n increases, Sn appears to approach 2/3. So 0.67 will be 2/3. And that will be the graph of it. Sums of infinite series. In example 1, you can understand why Sn approaches 1 as n increases by considering the rule for Sn. And then here is the rule for Sn. A to the first member of the series is 1 minus r to the nth over 1 minus r. And then 1 over 2, we plug in there. then we get 1 minus 1/2 to the n. As n increases, 1/2 n approaches 0. So as Sn approaches 1, therefore 1 is defined to be the sum of the infinite geometric series as in example 1. More generally, as n increases for any infinite geometric series with a common ratio r between -1 and 1, the value of Sn, a to 1, 1 minus r to n over 1 minus r, equals this here, a to the 1 over 1 minus r. That's what we find out here from this series up there. The sum of an infinite geometric series is given by this. So we just derive this formula. Provided the absolute value of r is less than 1, if the absolute value of r is greater than or equal to 1, the series has no sum. It would have no sum. Okay, for example, find sums of this infinite series here. We have this situation here, 5 times 0.8 I to the minus 1. For this series, a to 1 equals 5 and r equals 0.8. So we do our plug-in here, 5 and 1 minus 0.8 equals 25. And for b here, this is our series here. For this area, a to the first element is 1 and our r is -3/4. So when we do the plug-in here, it will come to 4/7. Okay, let's do a guided practice, taking this into account. And then students, this is your independent practice here. Okay, here is our series here. Our first element is 1 here. And then our r is -1/2. Our 1 is right here. So when we do our plug-in here, we come up with this here, and we come up with 2/3 for our sum of our infinite series there. Okay, for part 2 and part 3 and worksheets, and if you need online tutoring, email me here. Thank you very much.